Hello, welcome to Coding Challenge Bit Shifting. So this is the second part, sort of this Coding Challenge series about binary numbers that all came from me implementing this in the 7-segment display video coding challenge, and then everybody asking, what was that you did? This shifting and masking makes no sense to me. So what I did in the previous video, if you actually managed to watch that video, was I created this little interactive binary to decimal converter system. So this is a single byte with 8 bits, every bit being on. I don't know, maybe that should be white if it's on, black if it's off, it probably, whatever. But black in this case means it's on. And so you can see here, if I toggle all of them off, I have a 0, this is 1, this is 2, this is 3, this is 4. So I can just toggle these bits on and off and get the decimal representation of that number. Okay, so what do I want to do now? What I want to do now is add bit shifting to this. Well, what is bit shifting and why would you ever want to do it? Well, I don't know. I mean, I know what it is. Why you would ever want to do it? Well, I needed to do it with my 7-segment challenge, so maybe that's the reason why you'd want to do it. But let's talk about it. So let's say, for the sake of argument, that we have the number 0, 1, 0, 1, 1, 0, 1, 0. So first of all, I need to convert this into decimal. I don't need to do bit shifting, but just to sort of think about it. So let's think about that. This is 1, so this is 2 plus 8 plus 16 plus 64. So that's 80 plus 10 is 90. So this number is 90. Where's my eraser? Okay, so that's 90. Sorry. Ah! So what is bit shifting? So bit shifting, when you take any number like the number 90, you can ask for the computer to think about it in binary, which it's already doing. That's actually what it's doing, and shift the bits around. So I could say shift to the right, or I could say shift to the left, and I could say shift by a certain amount. So let's say I just say shift to the right by 1. So this is bit shifting, and what that actually does is it shifts all the bits over. So this is a 0, this is a 0, this shifts to here, that's a 1, that's a 0, 1, 1, that's a 0, and this is a 1. Now, interestingly enough, I can tell you that this is the number 45. I hope it's the number 45. Why? This is what's really interesting. Shifting the bits over by 1 is actually the same operation as dividing by 2. Think about the powers of 2 and how binary numbers work. Shifting to the other way, to the left, is multiplying by 2. Look at this. Let's be sure about this. This is 1, 2, 4, 8, 16, 32. So 40 plus 5, 45. I was right. So this is what bit shifting basically does. So in theory, does when you say 90 divided by 2, does it shift the bits? I don't know, maybe. But this is actually, I've heard, I think this is right, that this is a faster way to divide by 2. Of course, you can only do it with integers, and how floating point numbers are represented as bits is a whole other discussion. But now, what we can do is let's add this feature to our code. And by the way, we can shift by more than 1 at a time. I could shift by 4 bits, etc. But, all right. And you might be thinking to yourself, I don't get it. Why is this one a 0? Like, wouldn't there be some bit over here to shift in? Well, when you apply bit shifting, you can imagine that the number 90, if you were represented in 2 bytes, all of these would be zeros. So we can always sort of assume the thing to the right is a 0, and whatever is here gets shifted over and basically gets removed. So by the way, if we tried to shift again and divide this, we would get, what would we get? We'd get the number 22. We wouldn't get 22 and a half, because we get the integer value of dividing that by 2, which takes off the decimal value. Okay, let's add that. So let's go over here and let's add a button. Let's add a Shift B button. And let's say, and I'm just using Shift button equals create button, and I'll put this in the button. So now I see, oh, that's so tiny, but that's fine. So this is going to be my button. Whenever I click it, I'm going to shift the bits to the right. So how am I going to do this? Function. So let's say shift shift button, shift bits. So I'm going to write a function called shift bits. Cue all of the jokes about me being Daniel Shift Man. Shift man. Okay, what? A function with a C. And now is not a function. Shift bits. Shift button. Oh, shift button dot mouse pressed. This is the P5 DOM library that I'm able to attach a function as an event to when I click the mouse on this button. So now what I'm going to do is, oh, okay. Well, here's the funny thing is, I was doing this to show you about bit shifting. Oh, I guess I could take the, oh, interesting. Oh, look at this. Think about, this is really interesting. So there's a couple ways I could approach this problem. If you watch the previous video, all of these are like a bit object, and I can, I've kind of kept information about like its x and y, its diameter, and its state, and I'm rendering it. But what I'm actually going to do here is I can take the decimal version, right? So, so this is a little bit of code here I'm going to put into a function, which is just going to be a function like get decimal. So whatever the state is, I'm going to get, oh no, that's get binary string. This is going to return the binary string of whatever the visualization is reporting. So I'm going to say get binary string. So now I'm back to what I had before, right? But now in this shift bits, I can do exactly this again. So I want to get the binary string. Then I want to get the number, the value equals get equals binary to decimal of that number. Then I want to say val equals val shift by 1. So I want to shift the bits over by 1, but now I'm going to have to convert that back to binary. I don't actually have a decimal to binary function. What I want to say now is num equals decimal to binary, right, of value. So this is what I want to do. I want to be able to now, anytime I click this, get the conversion back to decimal. Oh, I have to write a new function. So this was binary to decimal. Now I need to write a function. I knew I would have to do this. I left this as an exercise, but I'm going to need it now. Decimal to binary. Now again, I could get JavaScript to do this for me natively with toString. So for example, if I just open up the console here and I were to say let num equals 90, I could say num toString 2. Oh, I'm done. Oh, maybe I'll just do this. It'd be really nice to just do this, but I'm going to do it myself. So what I'm going to do is I need to get, now I get a value in. Oh, I'm using these variable names in terrible ways. I need to do a refactoring of this with better variable names. And what I'm going to do is, I know I'm going to always do this as 8 bits. So this is a bit of a constraint. I don't have to be so super generic here. I'm going to say int I equal, oh no, not int. Let I equal 0. I is less than 8. I plus plus. And now, what do I want to do? I need to divide it by, so here's the thing. How does this work? I'm pretty sure this is how you do it. Let's say I'm going to take the value 90 and try to turn that into binary. So my theory here is that I'm going to divide by 128, divide by 64, divide by 32, divide by 16, divide by 8, divide by 4, and you can see what I'm doing here. I am taking the same thing I did, powers of 2, but I'm going to use the division operator. What do I get when I say 90 divided by 128? I get a 0. 90 divided by 64, I get a 1, remainder something. 90 divided by 32, oh, here's the thing. So what's the remainder? Oh, okay, so this is what I need to, the remainder here is, sorry, 64, 74, 84, 26. So this bit is going to be a 1, and now I take that, I don't do 90 divided by 32. What am I thinking here? This is not what I meant to do. Something fell over. So let's get rid of this 90 here. So this is 0, remainder 90, basically, right? 0, remainder 90, so that remainder comes over here. Now it's 1, remainder 26. That 26 comes over here. 26 divided by 32 is 0, remainder 26. 26 divided by 16 is 1, remainder 10. Right? 10 divided by 8 is 1, remainder 2. You can see where I'm going here. So I should be able to do this now. Come back over here to the code. It's weird how much fun this is for me. So what I need to do now, okay, so I'm starting with the number, and I'm going to say the binary bits I'm going to use a string, and I'm going to go from 2 to the 7th, I equals 0, I is greater than equal, I starts at 7, I goes down to 0, I minus minus. And the remainder, I'm going to need this remainder value. So the first thing that I want to do is call the divisor equals power of 2 to the I. Then what I want to do is I need to do integer division. So I want to say number, I want to say the answer, or the value, the bit value equals number divided by divisor. Number divided by divisor. Here's the thing. I'm going to use floor. So JavaScript natively is going to do everything as floating point. If I were in like the Java programming language, it would just give me without the remainder. So, and then I'm going to say the remainder equals I forgot something, but I have a whole video. Actually, Golan Levin came and did a guest tutorial about a particular operation called modulus, represented, I think the operation is called modulo, and maybe the symbol is modulus. I can never remember this. I'm going to get a lot of comments telling me the correct way to do this. I can just see it already. But this gives you the remainder of the division operation. So what I can do here, and this, by the way, this should be remainder, and remainder should be num, and then the remainder is the remainder modulus divisor, right? And now, and the bit value is bits plus equal bit value. Boy, is this possibly right? And then return bits. Where did I go? Okay, let's just see if this function even works. So one thing I can do, actually, I'm just going to go, the P5 web editor console isn't interactive, but I can go here to the canvas frame, and I can say, right, what was that name of that function? Decimal to binary. And if I have the decimal number like 90, I think that's right. It worked. Okay. 255. Yeah. Okay, great. So that works. So now, when I'm shifting, right, what was I doing? I was shifting, then I get decimal to binary, and then what do I need to do? Update. This is really in draw, right? In draw, there's a draw function somewhere. This is like update the states. What? Oh, no. Oh, no. Where do I do that? Oh, I did that here. So I need to update all the states. So, oh, look, I have a set state function. How convenient. So I also now, once I do that, I need to go through and set the state to num car at I. And this probably has to be a number. Oh, but maybe I have that in set state. Oh, it's Boolean, right? I forgot I had this whole crazy thing to take the string, which is 0, 1, turn it into a number, and turn it into a Boolean. Perfect. So it does that already. So now I can shift. Oh, boy. Divide by 2, divide by 2. Look at this. Oh, my goodness. So I can now bit shift. Oh, let's go back to 90, right? This is 90. Whoops. 90. Okay, ready? Here we go. This is going to be an exciting moment. No. Don't click there. No, get back to 90. There we go. So we now have interactive bit shifting. Now, you, the viewer of this, you probably want to add shift the other way. That wouldn't be too hard to add. I'd just add another button, shift the other way. Maybe I want to actually have like a slider, shift by a certain number of bits. Maybe I don't want to limit myself to 8. I want to have 2 bytes displayed. But there's all sorts of possibilities now in terms of how I can do bit shifting. Oh, I got to do bit masking. I guess there's going to be another video here. Okay, but there's a couple things I want to. I know everyone is going crazy that I have the black as on. Let's fix this. Let's make it more clear so I don't leave everybody in such a traumatized state. So I'm going to make the background 51. And then I'm going to, in fill, where I'm drawing it, I am going to, and let's use a ternary operator. I'm comfortable with them now. So I'm going to say fill this dot state. If this dot state is on, the fill is 255, or if it's off, 0. There we go. So this is they're all off. Now they're on. It looks weird to me. Oh, background 51 is like the same as the actual. Anyway, so, and I can shift now. It's crazy. Yeah, that looks better, right? I'm shifting down. Okay, I forgot about you, the viewer. All right, so, I don't know, thrill me with your weird, weird variations on this. I look forward to it. I do need to do something about bit masking, which I will do an ampersand, an and or an or, and Simon has been telling me, breaking news in the chat over and over again, I can also do XOR. So you can also do XOR as a bitwise operation. So thanks for watching this challenge, and I look forward to seeing what you make. Share with me stuff in the comments, all your corrections and complaints and happy thoughts or whatever, and I'll see you again in another video. Goodbye.